Okay, let's continue here in section 2.7 with finding inverse functions algebraically. So going back to the steps, first use the horizontal line test to determine if it has an inverse. So we're checking to see if it is 1-to-1. And x cubed plus 1, if you think about the shape of x cubed, it looks like that, and so it would be a 1-to-1 function. Check. Now let's follow the steps. For f of x, we're going to replace it with a y. Well, in this case, it's g of x, but no big deal. It's the same thing. So we replace g of x with y. Now we're going to interchange the roles of x and y, which means we're going to swap them out. The y becomes an x and the x becomes a y. Then we need to solve it for y. So I need to get y by itself. So I'll subtract this 1. I'll have x minus 1 equal y cubed. And how do I undo a cube? Well, I'm going to cube root. So I'm going to cube root both sides. And notice I'm cube rooting the whole thing x minus 1. That 1 is under the radical. Remember, cube root undoes the cube. So I have y standing alone. The inverse is the cube root of x minus 1. We're done solving for y. So step 4 says replace y with the inverse notation. So I'm going to replace y with f inverse. Let me do it the other side. So f inverse of x is equal to the cube root of x minus 1. That's all underneath that radical. Okay, let's do the same thing with problem number 3. First, let's decide if it's 1-to-1. And remember that square root shape is that arcing shape, and that arcing shape is a 1-to-1 function. So let's follow our steps. Let's replace f of x with y. Let's swap out the x's and y's. Let's interchange them. And now we need to solve for y. Well, in order to get y by itself, I'm going to have to remove the addition of 4 and remove that square root. I can't remove the 4 until I remove the square root first. So I'm going to have to square both sides to get rid of that square root. The square and the square root cancel out. So I have x squared on the left. On the right-hand side, I have y plus 4. And so to finish this, I just need to subtract 4. So y squared minus 4, x squared minus 4 is equal to y. When you square both sides, you don't put in a plus or minus. The plus or minus only comes in if you square root both sides. So I now have my inverse, f inverse of x is equal to x squared minus 4. Oh, you know what? I just realized I made a mistake over here. This function was a g of x. So when I write the inverse, it's not f inverse, it is g inverse. Just a slight mistake there. So let me sort of separate these. Okay, so there we are. We have the inverse, but big red note here. X squared minus 4 is a parabola. And a parabola is not 1-to-1. So anytime you have a parabola involved in these inverses, you have to actually cut half of it off. And I'll show you how to figure that out. Problem number 3 is the square root of x plus 4. Let's just do a quick little graph of that. Plus 4 is under the radical, so that means it's inside the function, so it's going to the left 4. So that square root has gone to the left 4, and it looks like that. Let's look at the inverse, which is x squared minus 4. That's the parabola that goes down 4. Well, we have a problem because I cannot use the whole parabola because it's not one-to-one. So in these cases, what we have to do is cut half of it off. Notice if I cut that left half off, I've got symmetry across this line, y equal x. So my parabola is just going to be the right half of my parabola, and so I need a restriction that x has to be greater than or equal to 0. That's this part of the parabola. I'm not going to consider the left side. I'm just going to consider the side where the x values are positive. So when I come up with a parabola, I have to make a restriction on its domain, and we could just write that as, x greater than or equal to 0. That's good enough. Not sure how WebAssign is going to ask you to do that, but I would just say domain would be x greater than or equal to 0, or we could use interval notation saying the domain is 0 to infinity. These are tricky, and you have to remember how these parabolas work with inverse functions. Let's look at this next problem. In this next problem, we're being asked to verify that two functions are inverses of each other. When you are asked to verify, then what you have to show is that f circle g and g circle f are both equal to x. That's your goal when you're verifying that two functions are inverses of each other. So let's work on f circle g. That means we're going to put the g function into the f function. What does that look like? It'll be 4 times x minus 9 over 4 plus 9. Well, this in front, this 4 is like a 4 over 1, and he cancels with the 4 over here. So what I'm left with is x minus 9 plus 9, which is x. Check. That's what I'm looking for. I'm looking to see if it's equal to x. Let's come over here and plug the f function into the g function. So here is my f function. I'm going to plug him into my g function. So he looks like 4x plus 9 minus 9 all over 4. And if I start some canceling, these two 9s cancel. When I cancel those 9s, I'm left with 4x over 4. The two 4s cancel to give me an x. If I get x in both of those cases, then they are inverses of each other. So that's how we'll verify if two functions are inverses of each other. So now let's look at the last problem in this section. It's going to pull all those properties together. We want to find f inverse. We want to graph f and f inverse, and then state the domain and range of each of these. So there's a lot involved here. So let's first start off with our f of x. We know that square means we have a parabola. That minus 3 means it's been shifted to the right 3. So 1, 2, 3, it's right there. It's being shifted to the right 3, so it would be my parabola that looks like this. Something like that. But since it's a parabola, we've got that freaky thing happening with having to cut part of it off because a parabola would not pass the horizontal line test, which means it does not have an inverse. However, if I cut half of it off, this is telling me to look at the right half only. So if I only look at the right half of the parabola and cut off the left half, that makes it 1-to-1. So this is just kind of a forcing element. It forces, come on, pen. It forces it to be a 1-to-1 function. So there is x minus 3 parentheses squared. the right half of a parabola. Okay, I'm going to go ahead and put in my line of symmetry. Remember, it's the line y equal x. It goes right through the first and the third quadrant. Okay, so I've graphed f of x. Let's find f inverse. So remember the steps we just went through to find f inverse. Sorry about that. I'm outside and just heard that car horn go off. Anyway, back to what we're doing. First, prove that it's 1-to-1, and it is. The second step is to replace f of x with the letter y. Then we have to interchange our x's and y's. Then we have to solve for y. And to solve for y, I have to get rid of this square. So I'm going to have to square root both sides. By square rooting both sides, I'm going to knock out that square. Square root, undo each other. But remember, when you square root both sides, you have to put in a plus or minus. Aha, this is another spot that could get you. When I put in the plus or minus, I have to actually make a choice. I can't have both plus and minus. I have to choose either the plus or the minus. Since I'm only looking at the right, the right half of my parabola, I am going to need to choose the plus on that square root. So I'm just going to take the positive square root of x. To finish solving this for y, I'm going to add 3, which gives me my inverse function to be the square root of x, but plus 3 is outside of that square root. So to write the inverse, f inverse of x is equal to the square root of x plus 3. Think about the shape of this guy. It's the arcing shape that's moved up 3 units. So it's going to be right here. It's the arcing shape that's moved up 3 units. So it's going to look like that. And take a look at these two blue graphs. They are perfectly symmetric across that line y equal x. That is my inverse, and this is my function. Pretty cool the way that turns out. The last part of this problem is to find the domain and range of both f and f inverse. Okay, so let's do that. Well, let's just do the inverse right here. Let's catch his domain and his range. So remember, the inverse is this arcing shape. So the domain is going to be 0 to infinity. And the range is going to, remember, bottom to top, it's going to be 3 to infinity. Let's look at the domain and range for the original function f of x. So it is this half of a parabola. Well, what's nice is they already gave me the domain for that half of a parabola. It's x greater than or equal to 3. So for f of x, his domain is x greater than or equal to 3. Or you could say it is 3 to infinity. The range for f of x, if I look at that half of a parabola, going from bottom to top, it's going to be 0 to infinity. Now take a look at the domain and range for f of x and the domain and range for the f inverse. Probably can't get those in the same screen. Domain for the inverse is 0 to infinity. Range for the inverse is 0 to infinity. They've been switched. The range for the inverse is 3 to infinity. The domain for the inverse is 3 to infinity. Notice that switching aspect. Okay, well, that is all for section 2.7. So now you need to go online and complete the homework assignment. So go online.